Problem number 3. Let's now first of all see the specification for the problem. So we want to calculate, this is actually a simple problem, but it's actually good for us to solve this first before the next one, which will be somehow built up on this particular simple problem. Let's see how we can calculate, given the input to the array of integers, and then we want to return an array of size 2. And the first index 0, is going to store the maximum of the entire input array. And also the second index, index 1, is going to store the minimum value for this particular input array. And the input array can be of any shape, either rectangular or maybe some irregular shape. Well, in this case, triangle. For example, it's very easy to see. You can see that here, the maximum for the input array A will be 12. And the minimum will just be 1. And of course, the example shows positive numbers only. But in general, it can be either positive or negative or even 0. Right? And then on the other hand, for this input array A here, the maximum will be 8, and the minimum will also be 1 over here, right? So that's about the problem we're going to solve. This one is rather easy. We just have to go over the array elements one by one. Let's say row by row. That's the most straightforward, the most standard way. And then we're just going to update the maximum value that we might write. We just have to keep updating the maximum value if the current elements is strictly larger than that, and we have to keep updating the minimum value if the current value is strictly smaller than that. So that would be our plan to sort this out. Let's now take a look. Let's go back to Eclipse and let's solve it. All right, let's now go to utilities over here. And then we're just going to follow this. Let's now just implement a new method here. So we can say public static, and we want to return an array of size 2. So integer array, and we are not going to do any calculation, so they remain to be integers. Let's say get maximum, and let's say get max and min. Just make it short. We're going to get max and minimum values. And then the input is going to be a 2-dimensional array, A. Right? And then it's a reference type, so we just return null, just for now. All right? So that's, just make sure it's spelled properly. All right, so that's about the method declaration. Let's now write a test to see what to be achieved before we specify how to achieve it by writing the code. Let's go to test utilities over here. And for now, I can just use, let's say, test number 1. I can just copy the array, but I'm going to change the contents over there in just a moment. Okay, but the structure will be very similar. Let's save some typing. Okay, you already copied that. So now let's rename from 1 to 5 over here. All right, and let's see. So we're going to change this to this particular layout over here. Input 1 should be this. Input 2 should be this, right? I'll write it down together with you. So now it's going to be 1, 10, 5, 7. 1, 10, 5, 7. 6, 2, 12, 9. 6, 2, 12, 9. And then 3, 8, 4, 11. 3, 8, 4, 11. So what about the output? Output is going to be an array containing the integer, the maximum and minimum. So that'll be integer array, and we're going to call get maximum and minimum. Right? That's the method we just declared. Input 1. And what will be the expected array? The expected array will just be let's say integer array over here. Okay. So expected will be just an array, and let's say we do maximum followed by minimum. Let's say. So maximum will be 12, and the minimum will be 1, right? That's something we already went through. So that will be our first test case. And let's do the second case in the same method. So that one is going to be, let's change it. You can also refer to the screenshots of the illustration. So that'll be 6253, 6253, and 481, 481. So there is a reason that I actually changed the layout for the contents, because I want to give you some extra exercise which I wouldn't have time to go through in the current video. I can try that. I'll tell you what the exercise is at the end of the video. Okay, 481 and also 7. All right, and then what about output 2? It's going to be similar. It's going to be an integer array, output 2, and then we're going to call this method here, get max min. Get max min. Okay, invoke on input 2, and then expected 2 is also going to be an array, and then the array is going to store maximum followed by minimum. So the maximum will be 8 and the minimum will be 1. Okay, so that will be the test case we want to pass. Let's now go back to utilities. Okay, so this method here will be rather easy to implement, but let's now still do it, right? To see if there's anything we need to explain. Okay, so here we're just going to declare integer max and also integer min. Okay, and we might simply just assume the input array is actually not empty. We can assume that, right? So we can simply just say the maximum is simply just going to be the leftmost corner of the array. We can say this particular elements over here, we can say this one is going to be the initial maximum and minimum. So this will be the initial maximum and also minimum. And then as we scan through row by row and also column by column, if there's any current element that should be replacing the current minimum or maximum, we should do the replacement. Otherwise, we'll leave it until the end of the iteration. So that's pretty much like how we calculate maximum or minimum in the case of one-dimensional array. The same logic. Okay, let's now go back to here. Let's say, and of course, we can simply just state over here explicitly about the assumption. Assumption. The input array A is non-empty. So there's at least one element there, at least one row, and that row has at least one column. Okay, that's the assumption. So here we can say A 0 and also 0. Okay, somehow my keyboard is not really okay. And also this will be the same for the minimum. Okay. Initial, maximum, and minimum are set to the top left corner, right? You can see geometrically is the top left corner for the matrix over here, or the two-dimensional array. So let me just put this comment over here. We put it here, and let's now try to do the walkthrough. So we're gonna do the normal walkthrough. We say for integer row is initialized to be 0. You might be wondering why not we just start from 1, but I would say it's okay to actually check just 0 0 just again, because that itself is not going to replace itself. So I think that's fine. That kind of slight redundancy, we can afford it. If you want to make it more optimized, feel free. So integer r is initialized to be 0, and then r standard a dot length and also r plus plus, and then for integer colon initialized to be 0, colon less than, you should know that very well, a at position r dot length, and then c plus plus. All right, very good. And then for every element that we are looking at, which will be a, r, and c, we want to say that if this particular element is strictly larger than the maximum that we have maintained so far, so that means the maximum should be replaced by a, r, c. Right? If you actually look up how we calculated the maximum for a one-dimensional array, we follow just the same logic. You're just going to scan through the array from the beginning until the end, and then what you want to see, the current element should replace the current maximum. If no, they go to the next one. If yes, you replace it. So that will be to handle the maximum. We do something similar for the minimum. And now, should it be if or should it be else if? Right? It's a very good question, right? Why don't I say else if, and then you tell me if that's right or wrong. If I say else if a, r, c, and then strictly less than minimum, and then I would say minimum is simply assigned to a, r, c over here. All right. So I would say, conceptually speaking, well, let's now get to the concrete example. Conceptually, the calculation for maximum versus the calculation for the minimum, they should be independent. However, when you actually do if else if, so that means these two statements are depending on each other, meaning that you only get to this if else if this particular branching condition is actually false. But whether this actually is false or not, conceptually, it shouldn't really affect how you calculate the minimum. So they should be independent. So I would say, conceptually speaking, it would be more appropriate to put if over here, to say they are completely independent calculations to find out the minimum versus the maximum. Even though we are trying to return them at the same time, but I should really think about they should be calculated independently, right? Another way to solve this problem here is you can say I want to have two sequential nested loop. I can say the first nested loop is going to solve just the maximum, and then I can copy and paste just another nested loop sequentially that's going to solve the minimum only. But why don't we just solve both of them at the same time, right? That's my point. All right, so now outside the outer loop, we're going to we're going to set up the result, right? So we can say integer here result is simply equal to, so it's going to be an array of size 2, maximum followed by the minimum. Or you can also use the new expression to create an array of size 2 and then assign result at index 0 to be maximum and also result at index 1 to be minimum. You can also do that. But let me just do this one, it's simpler. And then eventually going to return the result. Okay, again, I gotta spell it properly. All right, it's now done. Why don't we go back to the JUnit tests, and then let's now test it. Let's now run it. All right, so now it's not really passing over here. Oh, actually, number 4 is not passing. Why is that? Okay, so let's now launch the test. And we actually get a red bar over here. Red bar, at least you can see all the previous tests, they're still passing. So that's a good sign. Let's see what's happening here. I can, just by looking at the error over here, we can learn something from that. You can see expecting something over here. So this is actually some address. You can see whatever some identifier at some number over here. So this will be this like a address format in Eclipse or in the Java compiler that's trying to show to you. All right, so here it's really showing that we are trying to compare address with another address. Apparently these two are different addresses, but that's not really our intention. We want to compare the expected array will be the same contents of the actual array returned by the method. But we are not really meant to we don't really mean to compare their addresses. We just want to compare their contents. Maybe the assertion itself is actually wrong. Let's go back here. Yes, indeed. So rather than saying assert equals, so whenever you say assert equals, either you want to assert maybe some integer values, some primitive values. But if you want to assert about array, we want to say array equals, right? Remember? We actually did that before, but it's a very common mistake, which I just made. So I'm going to say array equals, and then I'm going to say assert array equals over here. All right. Let's now try again with the JUnit test. Click on that. Okay. So now we pass all the test cases. Let me give you one exercise to do, and then before I conclude the video. The exercise I want you to do will be very similar to problem number 2, where we wanted you to calculate the row averages. So now we want you to calculate the row minimums and also maximums. Basically, for every row that we have, we want to calculate for this particular row, what's the maximum and what's the minimum. And then for this particular row, what's the minimum and what's the maximum, right? Let's now just do, let's not get too complicated by calculating both the maximum and minimum. Why don't we just say maximum, and minimum would be kind of symmetric. Let me now put the exercise down, and let's see what you should do. So this will be some exercise for you. Okay, I will highly encourage you to try. So declare some some utility method in the utilities class. You can say public. Let's say integer array, and then let's say get row maximum. Okay, and then the input will just be integer array, 2-dimensional, and also a over here. Right? So this will be something you want to implement. So that would be your exercise. Let's see for one example. For this particular input, what should be the expected array to be returned? First of all, the size of the return array should really correspond to how many rows you actually have. Here you got 3 rows. And then, what's the maximum for each? The maximum for the first row should be 10. The maximum for the second row should be 12. And the maximum for the third row should be 11. So eventually, what you want to return over here would be if you say get row maximum and you call A. So this should really return an array for this particular A over here, of course. So that should return 10 and also 12 and then 11. So that would be the method I would like you to try. Okay, get row maximum. And after that, you can also try get row minimum. Not only that, I want you to really implement this method here. So number one, you want to increments. And number two, I would also like you to actually test it by writing some test cases. For that, you can simply copy and paste what the test cases we did for row averages, that particular method, and then you can adapt it accordingly. All right, so that's about this problem number 3 I would like to speak about, and let's now move on to problem number 4.